Let's play a game with fractions. So what we will do is that first I will shade some portions and you have to tell me what portion has been shaded. Well, we have a triangle here, and in this triangle I have made four different triangles. Do you see? 1, 2, 3, 4. In this case we have a circle, and how many triangles do you see? Circle has been divided into 1, 2, 3, 4, 5, 6, 7, 8 parts. And then we have a hexagon, and hexagon has been divided into 1, 2, 3, 4, 5, 6 parts. And here we have a rectangle, and rectangle has been divided into 1, 2, 3, 4, 5, 6 parts, right? Now what we are going to do here is that I will shade two parts from each, right? And you have to write down it in fractions. You write it down in fractions, and then I'll let you know the answers. Then check your answer, okay? So I'm shading these two in pink color, right? That is what I'm shading. You write down the answer. If I'm shading two out of these, how many did I shade? And if possible, write two different fractions to describe this shading, right? So I'm shading here these two. So write opposite ones. Tell me, how many did I shade? What fraction did I shade? Okay, now in hexagon, I will do two of these. Now in the rectangle, let me select any two. So which ones? Let's say these diagonally opposite ones. You need to write down in fractions what portion has been shaded, okay? That is your job. Now once you do that, then check answers with me. So in the first case, what is your answer? We shaded 2, right? So let's write 2 for here. And out of how many? There are 4 triangles, so it is 2 out of 4. Now in the next case, we shaded how many? 2 again, right? So 2 out of how many? 1, 2, 3, 4, 5, 6, 7, 8. So it is 2 out of 8. Now in the hexagon, we shaded 2 and 2 out of 6, since there are 6 triangles. Now in the last one, we shaded how many? 2. 2 out of 1, 2, 3, 4, 5, 6. Is that the right thing? I don't think so. Why? We cannot write this as 6. You know why? They are not equal. Do you see? Are they equal triangles? No, they are not. So they are not equal fractions. Therefore, we cannot write this in a fraction, correct? So this one cannot be written. So we'll just cross it out. But these are correct. 2 out of 6, 2 out of 8, and 2 out of 4. Now, we know this much, but now let's extend this. And that is, can you now tell me another way of writing these fractions? That means we are looking for equivalent fractions. Equivalent fractions. Can you tell me? Think about it. So I'll tell you how to do it. Now for the first one, 2 out of 4. We can do half of both numerator and denominator. So if you divide 2 by 2, what do you get? 1. So it becomes half. Do you see? 1 out of 2. Here, let's divide 2 by 2. You get 1. And half of 8? 4. 1/4. Do you see that? In this case, if I divide by 2, both numerator and denominator, I get 1 out of 3. 1 out of 3 has been shaded. Now, how do you show it? I will show it. How do you say 1 out of 3? Consider half of it. So this is another way of showing. Do you see? Out of these 3 triangles, how many did I shade? 1 out of 3. Out of these 3, how many did I shade? 1 out of 3, right? In all, 2 out of 6. This is one way of looking into it. Do you see that? That is also a way to look into it. Let's go through this one. 1 out of 4. So, consider 1/4 of it. So, let's say 4. So, let's shade 1 and then out of 4. That means 1, 2, 3, 4. That means in this half, we shaded only 1 and then again shade 1 and leave 3. Do you see? So, in 4, let's say there are 4 triangles. What did you do? You shaded one of them. You shaded one of them and left 3 blank. That is the meaning of 1 out of 4. From every 4, group of every 4, you will shade 1. Another 4 group, shade 1. So in all, you got 2 of them shaded. Do you see that? When I say half is shaded, that means from 2 equal portions, you selected to shade one of them, right? So you shade 1 and so you get like this. Then again, from next 2, shade 1. So in all, from 4, shade 2. So that is another way of looking into fractions and equivalent fractions. Do you understand? So that is how we can shade our triangles and then write them in fractions in 2 different ways at least, correct? So, and one more thing which you learned here is that whenever we are talking about fractions, you should not forget all triangles, all shapes. When we divide them, we have to divide them into equal parts, right? In this case, this is bigger. Do you see that? And that is small. And therefore, we cannot consider that to be as equal fractions, right? So that is not a valid answer. But these all parts are same size, and therefore we can write them as fractions. So in fractions, numerator is number of shaded or selected portions, and denominator is total number of equal parts. Do you see that? Remember that. So whenever we write fractions, we should have equal parts, and denominator will be fractions like this. So it is total number of equal parts. And in the numerator, we write number of selected parts. Do you see that? So that is the way to write fractions. So a number over another number. Let's say A over B, where A and B are numbers for us, correct? Another thing to remember is that you have to divide them into some parts. B cannot be 0, right? You cannot have 0 here, right? You have to have a number, not 0. So there has to be at least some number here, okay? It may be 1. If it is 1 whole, then you get improper fractions. Remember that also, okay? So I hope that recollects all the things which you learned before this video. Thank you and all the best.